Hello and welcome to Spectacular Science, How to Make Lemonade Fizzy. This is a really fun station that talks about states of matter as well as some simple chemistry. So to start off, I would ask the students, the children around, if they like sodas, if they like 7-Up, and if they like the fizzy drinks. And then ask if they'd like to learn how they can make a drink fizzy. And the drink we're going to use is lemonade. And we're going to learn 2 different ways that you can make it fizzy. But before you can do that, you need to learn a little bit about lemonade. Lemonade, as I have here, is what we call a liquid. Now, if children are already familiar with the states of matter, you can simply ask, what state of matter is lemonade? If they're not, you can explain that lemonade is a liquid. That's the form that it's in. There are 3 different forms or states of matter, 3 different forms that things can be. One is a solid, something that's nice and strong and keeps its shape. The other is a liquid, like our lemonade. It can kind of move around. And the final is a gas, like the air that's around us. Well, your fizzy drinks have gas inside them. They have a liquid mixed with some gas inside it, and that's what makes them fizzy. That's what makes them carbonated. So in order to make our lemonade fizzy, we have to get some gas particles, some gas air bubbles inside our lemonade. 2 different ways we can do this. One is to physically put air bubbles into there. Now the way we do that is with some dry ice. Now dry ice looks a lot like ice, but it's a little different. Ice is made of frozen water. And if I stuck just your normal standard ice into lemonade, what would happen? And you can ask the students what would happen to it. Well, it would melt. It would turn into liquid water, because that's what water is usually like at room temperature. But this is carbon dioxide, which is normally a gas at room temperature. Right now it's frozen, so it's a solid and it's really cold. When I put it into my lemonade, you can see all sorts of gas bubbles coming out. That's because at room temperature, and when you warm up the solid frozen carbon dioxide, it goes right to a gas. That's what it likes to be at room temperature. Water likes to be a liquid. Carbon dioxide likes to be a gas. And so when you put it into your lemonade, you're introducing little gas bubbles in there. Now a lot of them are coming out, as you can see. I'm going to blow it here. If you're looking in there, you can see lots of bubbles of gas escaping. But a lot of them are staying dispersed in that liquid, and there you have fizzy lemonade, carbonated lemonade. So there's one way we can do it. This is a physical change. This is introducing your solid carbon dioxide into your liquid lemonade, and the result, you have air gas bubbles, CO2 gas bubbles in your liquid, giving you your carbonated beverage. Now the other way you can do this is through a chemical change. Now in a physical change, the carbon dioxide didn't change. It was still carbon dioxide. It changed from a solid to a gas, but it was still the same thing, just in a different form. But when you change things, when you do this in a chemical way, you're actually changing the things that you put together, so they become a totally different substance, not just a different form. So over here, we're going to go ahead and use our lemon juice. We're going to do a tablespoon of lemon juice and a tablespoon of sugar. With kids around, it tends to disappear. So we're going to do a tablespoon of sugar, a big heaping tablespoon of sugar on this one, and a tablespoon of lemon juice. Now in this reaction, in this chemical reaction where we're changing the things we put in, lemon juice is a type of chemical that we call an acid. And the sugar actually isn't really going to change anything in here, it's just going to make it so it's more fun to drink. So right now we're not changing anything, we're just stirring, we're dissolving the sugar, and we're not actually changing any of the chemicals in there right now. However, I'm going to add 1/8 of a teaspoon of baking soda just a tiny bit here. Now, the baking soda is a type of chemical that we call a base. So we have your lemon juice, which is an acid, your baking soda, which is a base. And when you put these two chemicals together, they react, they change each other. And you get, and you can look in here and you can actually see it fizzing as a product of their change. You actually get carbon dioxide gas bubbles. Same as we got over here with our physical change, but now with the chemical change. Some of the acid reacted with some of the base and gave us some carbon dioxide bubbles. And you can see them in there very clearly. Now that's pretty strong lemonade, so we're going to put our cup of water in here. And stir it up. And you'll have some fizzy lemonade. Not bad. So again, our acid reacted with our base to give us, again, the same thing we got over here, carbon dioxide bubbles, but in a different way, in a way where they changed each other to produce the carbon dioxide. Now you'll notice not all of the lemon was changed and not all of the baking soda was changed, otherwise it wouldn't taste much like lemonade. But some of the lemon juice reacted with some of the base, baking soda, to produce our carbon dioxide bubbles. So that's two different ways that you can make your lemonade fizzy, both by doing a physical change from a solid to a gas, and by doing a chemical change, using two different chemicals and putting them together and watching them react and change each other. Thanks for joining us.